Wow. I want to apologize to start with. I'm a little bit enthusiastic. I'm very excited to be here, and I'm also very excited about what I want to share with you. So if I feel a little too exuberant, I want to apologize in advance. I'm an American, what can I say? And I want to talk to you about 5 practices that I think are really valuable for software development. There's, of course, the Agile movement, and I was recently last week in the Deliver Agile conference in Austin, Texas. That's the sort of the technical conference on the US side. There was 300 people there. And it was a wonderful conference, but coming here and seeing 2,000 people is amazing. And it's so great to see that people are taking craftsmanship really seriously. I think it was to me, the central message of the Agile Manifesto. And somehow that message got a little bit lost over the last 2 decades. Software development, I mean, Scrum and all, very valuable, but there's more to software development than just having stand-up meetings and doing 2-week iterations. There are a whole bunch of technical practices. And in my experience working with lots of companies around the world, that it's these technical practices that really give us the leverage, that gives us the ability to get more work done with higher quality. And unfortunately, I don't have any silver bullets for you. The best I can come up with is that if you really want to develop rapidly, that paying attention to quality and understanding not just those practices that they talk about, but why those practices are valuable, the principles, the reasoning behind them, I think is really valuable. I've got a chance to work with thousands of professional software developers in my career. And my burning question, the thing that I've really spent my life looking at and thinking about is, when I meet someone who is maybe 10 times or even sometimes 100 times more productive than an average developer, my question is why? What makes them so good? And so I've studied these people because they've shown up in my classes and I've seen them in the industry. And what I noticed is that these people maybe have a few practices that they do that are kind of unique or that are mostly unique. They have their own terminology. They sort of think a little bit differently, but all of these things are learnable skills. And what I've discovered is, if we think the way they think, if we do the practices that they do, we can get the same results. And I think that's really, really exciting. So a couple of years ago, I wrote a book. It's called Beyond Legacy Code. And I really wanted to talk about not just the practices, but the reasoning behind them, the purpose behind them, and make it accessible to even non-software developers. Because I notice in the United States that there's a disconnect between management and development. And then we're not always on the same page. And I wanted managers to really understand what we developers kind of go through. So I want to ask you guys a couple of questions to start with, and then a few more questions later. So how many developers do we have here? Oh, my people, yes! That is awesome. That is awesome. How about managers? How many managers are here? And a good group of managers, too. Excellent. Well, you're very much welcome to be here. And then, bless you, there are the others. How many, like testers, the QA people? Oh, beautiful, awesome. Consultants, how many consultants do we have? Oh, just a few. Oh, in the back, hiding. Did I miss anyone? Any other? Well, just call us other. Okay, good. Excellent. So let me see if I can get my slides going here. It should be on. Do we have slides? Yes, thank you very much. Good. So my website is called To Be Agile, and this is how you can contact me if you have questions after. And of course, I'll be at the conference as well and hanging out. This is actually a diagram of some of the material that I teach in my courses for software developers. It's not, someone asked me once, is this religious? No, it's not a religious diagram. It's a very common technique in education to map concepts to geometric shapes because it's more memorable that way. And as you can see, there's some things that you probably are familiar with, some principles like the open-close principle, OCP, or the list-gov substitution principle. Some things are practices, like building in sprints or hide-by policy. Other things are disciplines, like writing the test first or doing refactoring. And then they're all surrounded by 6 key code qualities, like cohesive, encapsulated, testable, things like that. There's only like 18 things here, and then together with about a dozen design patterns, builds the foundation that I think all of us developers will benefit most from. So I want to point out that this is just a finite set, a very small set of information, but it really helps us get on the same page. And this is where I find that we have the biggest challenges of developers in development, because we have different perspectives, and this is also really awesome. And we really want to encourage this in the community. I was at the Scrum gathering just last month or a month and a half ago, and a couple of things that was really encouraging to me about being at the Scrum gathering. First of all, they let me in, which I was really pleased about, because I apply every year to talk a little bit about some of the technical practices that underlie Scrum. And sometimes they're like, yeah, we don't need technical practice. But they actually had 3 technical sessions there at the Scrum gathering, and mine was packed. It was really great to see. And then the other thing that was very exciting about being at the Scrum gathering this year was that about 40% were women. And that's kind of a breakthrough for us in the States, because it's kind of been a male industry. And I see a lot of people who are very similar to me too. That's good, but we want to also encourage a lot of diversity in our industry, because it really encourages us. It really helps us get new perspectives as well. I think all of that's really good. The challenge is that we have different ways of thinking and different approaches. And I think if I asked you to write me a significant program, each of us would maybe come up with somewhat different designs. And all of them are equally valid. There's no right and wrong here. But the challenge is that when you take your piece and integrate it with his piece, that maybe they don't integrate so well. And so having common touch points, I think, is so important and so valuable. And that's what these 18 practices and principles do for us. And that's also what test-driven development does for us, I think. Because maybe we can't agree on exactly the right implementation, because there's many valid ways to do things, but we certainly can agree on the right tests, the right unit tests to write for a particular behavior. And I find that that provides enormous amounts of consensus for us. And again, this is the thing that I see that we're kind of having a challenge on, is that we have these multiple valid ways of doing things, and we're asking ourselves, well, what's better? And I think testability and test-driven development can help guide us in that area, but I get ahead of myself. I want to talk to you about a few other things first. This, again, is me, and I have written a book. It's called Beyond Legacy Code, and it's available on Amazon or from my publisher, Pragmatic, if you go to beyondlegacycode.com. So what is legacy code? And I think, Michael Feathers wrote an amazingly great book, and this book is very different than Michael's book. His book is called Working Effectively with Legacy Code. It's filled with great techniques for being able to tame legacy code, which I think is quite important for us. My book is not so much about that. I cover a couple of techniques, but really, my book is about how to not get there in the first place. So I talk about different practices that help us prevent us from getting into legacy code, and really focus on what good code looks like in these 9 practices. And then at the very end of the book, now that we know what good code looks like, we take all of those practices and apply it to legacy code as well. Okay. But it's a book that you could give to your manager to read, or you could, if you're a manager, give to your development team to read, which is interesting. Because it's talking about, again, the reasoning behind the practices. There's a lot of how-to books out there. I call this a why-to book, because it's really about the reasoning behind the practices. So I have some questions for you. And just tell me by show of hands. And by the way, I've asked this question at the Scrum gathering a couple of weeks ago, and I've asked this several other years at the Scrum gathering, so I'm very interested to see your responses. So my first question is pretty obvious. It's a very simple question, especially if you're in the Scrum gathering where you're always doing Scrum. How many people here are doing Scrum? Like 90% of the teams raise their hand. That's great. Awesome. And you've been doing it for a while? How many people more than a year? Oh, very many. How about 2 years, 5 years? Oh, notice though, and I see this a lot, people going down at the 5-year mark and beyond, because you can do a lot of the processes for about 5 years, but if you don't pay attention to that technical debt, it kind of eats you alive at that point. So I see that Scrum teams tend to break down when they don't do the technical practices in the 5 to 7 year time frame. So, and a lot of times Scrum teams are like, oh, we'll get to those technical practices later. I find that it's better to do it up front. So now, here's the question, and this is, I'm hoping that you're going to excite me on this answer. So how many teams are doing XP? I want you to guys look around the room. 1, 2, 3, 4, 5, 6, 6, at the, maybe 8, 10. At the Scrum gathering, 3. 4 years ago, 2. 7 years ago, 1. Me. Okay, so I want to, and I won't even ask you how many years, because there's only a few of us. But I will ask the people who were doing XP, what kind of technical practices are you doing? Are people doing continuous integration? Oh, good. Many, many people are doing continuous integration. How about unit test-first development? And I see a subset of those people. I think that in order to do CI really effectively, we need to have good unit tests, tests that we totally trust and rely on. People are doing refactoring and stuff like that. Okay, I got a good flavor. That's good to know. Now I want to share with you, you probably are familiar since pretty much everyone said they were doing Scrum. This book really started it all out. Agile Software Development with Scrum by Ken Schwaber and Mike Beadle. I want to just read to you the last 2 sentences in the description on the back of the book. They say, this book shows readers how to use Scrum, an Agile software development method process, to quickly and seamlessly implement XP in their shops while still producing actual software. Using Scrum in an Agile process can virtually eliminate all downtime during an XP implementation. So clearly, according to the authors, the people who created Scrum, they created it to help us do XP more effectively. And here we are in a situation where pretty much everyone's doing Scrum, and we got, less than 10 people doing XP. This is not unusual. When I look at the community, I've done a lot of study on the US community. It's about 1 in 10 teams are doing extreme programming. And in my experience, about 1 in 10 of those teams are doing it correctly, which leaves us to about 1%. Now that 1% actually are doing amazingly well. And when you look at that 1% of the teams that are really successful with it, they're doing phenomenal. Those are achievable for us as well. And as far as I can tell, again, is that they understand what's behind these practices, which is what we'll be talking about. So here are the 9 practices from my book. We're going to just focus on 5 of them, these 5. And the reason I can't cover all of them with you is I have just a short amount of time. Okay. The first one I want to talk with you, the first practice, is called integrate continuously. So continuous integration, which many of you said you are doing, which is awesome. I think the DevOps movement is really, really powerful. And for one reason, it's providing a context for these other technical practices and why they're so important. And I have here a picture of these 2, I don't know what they're called, even in English, but these are, you can see them on the top of police cars, you know, these flashing lights. And I have it here because I was given a tour by a friend of mine at a true XP shop in Seattle where I live. This is about 5 years ago. And he was taking me through at night where no one was there, and it was beautiful to see because they had pairing stations everywhere and team agreements on the wall. And there was this hardware in the corner there, this big gnarly piece of hardware. And I said to my friend Thomas, Thomas, what is that? He said, oh, that's our integration server. Let me show you what happens when somebody breaks the build. And he logs into a workstation, types a few keys, and suddenly all the fluorescent lights in the building shut off. And the blue light turns to a red light, and a siren goes off. I thought it was the fire alarm, so I got up and I'm ready to walk out of the building, and he's like, no. This is what happens when somebody breaks the build in our organization, he said to me. He said, we don't tolerate broken builds in our company. And actually, if you're a person who broke the build, then there's a fireman's helmet right by the big build server. You have to go put the fireman's helmet on, like a little dunce cap, and you have to fix it right then and there. You can't go to the bathroom or anything. Because again, people were so dependent on the build. And you guys, as you get more and more into CI, you see that it really is so incredibly valuable and powerful. Two of my friends here are actually here this week, and if you get a chance to meet them, they're some of the most brilliant people I know. Llewellyn Falco and Arlo Belshi. And when I look at their server logs, when they're coding, they are pretty much doing test cycles and running their build on average, and this is not the full build, but just their small build on their local machine, on average about every 20 seconds or 3 times a minute. We talk a lot about feedback in Agile. Imagine how powerful you would be if you had that level of feedback coming at you all the time. And for me, this is one of the reasons that I have really amazing superpowers as a software developer, because I'm being fed tons of information from my build, helping me understand better. So I think of continuous integration really as the heartbeat of a project. And it's I think, the best place to start with the technical practices, because it provides a context for other technical practices as well. I think about 3 kinds of done. There's done, which means that it worked on the developer's machine who wrote it. We're all familiar with that version of done. And then Scrum has a version that they call done, which means that it works and it's integrated into the build, and that's great. But I think it's not enough. So I have another definition. I call it done. And done means that it runs, it's integrated into the build, and it's refactored for supportability. Supportability is a critical concept, and it's in every other form of engineering, productization, but we don't know how to pronounce those words as software developers sometimes. And we think, we can build a prototype and then ship it. And this is one of the reasons that it costs 5 times more to maintain code once it's out in the wild than it costs to write it initially. 20% of the cost of software happens when you're building it, and 80% is after it's released. And by the way, the smallest amount of that is maintenance. I was really curious about that figure, so I dived into it a little bit more. It turns out that bugs that escaped into production on average, and this is an NIST study that's pretty well documented. It's hard to find good studies in our industry. So fixing bugs costs about half as much as it cost to originally build it. And providing minor enhancements, I don't mean major, but just minor enhancements, costs twice as much as it cost to originally build it. Think about that for a minute. Like, wow, why? Why is it so expensive? Because primarily we developers write software in a way that is very hard to extend and to change. But as we look at the life cycle of our code, that's what's needed from it. So these are not the quick and dirty practices that I'm talking about, but these are the practices that support us in being able to extend our software in the future, because it turns out that that's really important, right? So I'm a big believer in continuous integration and continuous deployability. But when I say this, I'm not saying that we should deploy every time we come up with a new feature, necessarily. When we deploy, when we ship is a business decision. And it's based upon the seasonality of our products and our maintenance contracts and many other business cases. So let's let the business manage that. But I believe that for most of the software that we build, we should always build it so that it's releasable. And the reason that I say that is that it tells us the truth. Because it's very easy to confuse ourselves. You know, we can come up with thinking that we're almost done with a project, but once we integrate, in the integration phase, we see the nastiest bugs. So if we integrate continuously, we see the truth on a small scale. We see that our system actually works. And I think that's very valuable and powerful. And we get that level of feedback I was talking about. So automate the build. And I want to make it so brain-dead simple to use the build that every developer will use it all the time. So a single click. and constantly integrate. I was, and this is about a year ago, I was working on a project, and I like to come in early in the morning because there's no one there and I can get a lot of work done. So I'm sitting there working, and I didn't realize it, but one of my colleagues came in and was standing behind me. And I run the build, and everything's green bar. I love green bar, it's so nice. So I got green bar, and I click it again, and I get green bar again. And my friend interrupts me, he says, "David, what are you doing? I just saw you run your test twice without making any changes to your code. You don't have any ephemeral dependencies, things that are flaky in there, because you know that's a big no-no." I'm like, no, I know that, I've heard that lecture before. "It just feels good," I said. And it's true, I love to see the green bar, so sometimes I just hit it a couple of times, and it kind of is like a shot of espresso for me. It kind of wakes me up, gets me going again. So if you're not doing CI, I really strongly suggest it's a great place to start with the technical practices. If you are doing CI, we'll talk about some ways of doing TDD that will help you do it better. Because once you have total trust in your system, it's so powerful and so useful. The stress goes away, and you can see that I'm a guy who's got a fair amount of stress in my life. You know, I've been a waterfall developer for 15 years before I was an Agile developer. And now I can sleep, jet lag aside, I can sleep well at night, which is really good. Okay, I want to talk to you also a teeny bit about collaboration. This is also, I think of it as a technical practice, because a lot of us assume that we can collaborate just naturally, but there are techniques, there are practices around doing it well, just like any of those other technical practices. This is a picture that Ron Jeffries gave to me of the original C3 project where extreme programming was born. And it gave him a basement and smashed a bunch of tables together, but you can see that you have pairing stations and people are working together in teams and stuff like that. And you know, we software developers have a reputation of being kind of reserved and quiet and not good at conversation, but I don't really believe that at all. We deal with very complex concepts, and we have to communicate them. So I think we're amazing communicators. Maybe at a party we're not great at small talk, but I think in terms of the bulk of our communication and communicating complex concepts, we're great at it. And we have to be, because it's a large part of what we do. We have to, when we're doing enterprise software development, we have to collaborate a great deal. And it's very different than the kind of software that we built when we were in college, you know. Small projects, these practices don't really matter so much, but everything can scale up. So when it scales up, that's when these practices really matter. So pair programming, and this is the one practice of extreme programming that I get the most resistance from, both from developers and from managers. Actually, it's really easy to convince developers of pairing and the benefits of pairing. Just let them do it for a while and have them experience the value of it. And I don't really necessarily mean that you should pair all the time. It's very exhausting to pair. So if you can pair 4 hours in a day, that is amazing. But I find that we can learn so much from each other. And one of the things that I do, well, this is a great conference and there's a lot of great sessions, but some conferences I go to, sometimes I blow off the sessions and just pair with a colleague for the day. And I find I learned so much that way. Sometimes I can't convince developers to do pairing, so I do what I call buddy programming. It's kind of a gateway practice to get you to pairing. We work on our own for the entire day, but at the last hour of the day, we get together with our buddies and we do a code review. And after a few months of doing that, oftentimes people will be more receptive to pairing. And then my friend Woody Zuhl came up with this notion of mobbing. How many people are familiar with mobbing? Oh, great, see? It's catching on so nicely. And mobbing is where you have a lot of people who are the navigators and one driver. In this case, it's Chris, the gentleman in the black shirt, who's driving, and all the other people are navigators. And it's amazing how efficient we can be when we do it. And I'm not saying that, again, we should do it for all projects, but especially when we want to learn something together or get on the, start building a software that has a collective code ownership so we can use the same approach and style. It's really useful. One of the things about doing extreme programming is that we don't necessarily know everything up front, before we go in to start coding. And we find that it's more efficient because we can visualize and understand what we're doing better in the moment rather than trying to think about it months before. But it means that we're walking in with lots of unknowns. So what I do when I hit an unknown that stops me, like, I need to do this and I don't know how to do it. Maybe there's a library out there to do it for me. I just do a little research. I call it a little time box. And so I'll say that for over the next 20 minutes or 4 hours or whatever, I'll address these questions. And then at the end of the time box, I'll check in with myself and see if I've addressed it or whether I need to do another time box or whatever. And I find it's also, again, very efficient to do it that way. When we're pairing, it doesn't necessarily negate retrospectives and code reviews, but I find the tenor of these things change quite a bit. Rather than arguing about formatting, we start to talk in code reviews about why we're doing things. Oh, I was taking this approach for these different reasons. And so I think it's more productive and valuable. The other thing that I find incredibly valuable about pairing is that it amplifies learning. In fact, it's the fastest way to propagate information I found across a team. So that's really, really powerful. Also, at the end of a day of pairing, I am exhausted. I am completely wiped out because I've worked really hard, you know? But I'm also supremely satisfied because I got a lot done and I learned a lot. So this is, for you managers, one of the compelling reasons, really, to think about having your teams pair. You're not losing 50% of your resources, because first of all, we're not resources, we're people. And secondly, it's not 50%. The studies show that maybe it's a reduction of 15% in a worst-case scenario of productivity, but that's more than gained because we're producing code with far less bugs, and we're producing less code to do the same task. And also, we're more focused because you're much less likely to be interrupted when you're pairing with someone, you know, somebody walking by from the water cooler and going, hey, you know, how about that soccer team and how about whatever. So people let you work more focused. And again, managers, this is a very good reason to have your teams try pairing. And the other thing that my mentor, Scott Bain, says to me, and I think is really valuable, is that we should always be mentoring and mentored. And I'm very fortunate that I'm part of this Agile community like you are, and I get to hang out with you guys and other people and learn from us. We learn from each other, which is awesome. This is something that other professions have. Doctors go through residencies, and lawyers go through a period of time where they serve under a judge or another lawyer. And we need this as well in our industry. We're a rapidly growing industry, and we need to preserve that knowledge and share it and be consistent. The next code quality I want to talk with you about, practice, I call create clean code. And clean is my acronym for 5 key code qualities. So I'm sure you're familiar with the notion, Bob Martin's notion of clean code. There's also the Clean Code Talks by Misko Havery. It's a Google Tech Talk, series of Google Tech Talks. If you haven't seen them, I highly recommend them. And since I'm a developer like you guys, I thought I'd overload the term and give another meaning to the word. So clean stands for these 5 code qualities that I want to just briefly go over with you because I think that they underpin all good code. So the first one is cohesive, and I'm sure you're familiar with these ideas. Just want to touch on them again so they're top of mind for us. Cohesive means that our code, that our entity, like a class or a method, is about one thing. As my esteemed colleague, Dr. John Rossthorn says, no schizophrenic classes. Scott Bain says, keep entities single-minded. Al Shalloway says, no God objects. When I said to Al, why do you call it a God object? Because it tries to do everything? He says, no, I call it a God object because when I look at the code and go to change it, I go, oh my God, right? You know what I'm talking about. So we use the single responsibility principle, making our entities about one single responsibility. And sometimes when I talk to developers, they're like, oh, in order to do that, I got to create a separate class. And that's really hard. What is that, 8 characters I have to type, C-L-A-S-S, and then those 2 curly brackets, which I have to do the shift at the same time. That's a lot of work. But if we think about, if we have 5 issues, just 5 issues in the same class, how many unit tests do I have to write to ensure that these issues don't interact with each other? Does anyone know? The formula is 2 to the nth. So 5 issues would be 32 tests, plus integration to ensure that they works correctly. 32 tests, fair amount of tests. Let's say I have 5 issues in 5 separate encapsulated classes. How many tests do I need to write? Unit tests. Just 5, plus integration. Which would you rather do? Write 5 tests or write 32 tests? Personally, I'd rather write 5 tests and get home for dinner, right? So when you set the game up in the correct way, the easy approach is the correct approach. And this is what we need in our industry. Because we are human, and human beings are all about gaming things. And I'm not saying this in a bad way. This is how we created civilization. I'm very proud of the fact that we're gamers. So we have to set up the right incentives. And one of the key incentives, I think, one of the things that we must take as a fundamental principle in software development is these code qualities are important, or testability is important. And when we gain testability, we're on the right track. Okay? To me, testability is a lens that when I look through it, I get clarity about what is a valid approach, what is a really good approach, and what is maybe not so good approaches, which I think is really valuable. Second code quality I want to touch on, and I don't have very much time, is quality code is loosely coupled. So we're talking through abstractions. This allows me to make my code functionally independent, so I can test little pieces. Again, testability, interestingly, comes up as something that's fundamental. So if I can make little pieces testable, then my code is much more modular, instead of fully intertwined. And most of the code that I see in this day, and I'm talking about the top companies in the world, it's all one big rat's nest of everything's intertwined, and that's why it's so hard to work with. We also want to encapsulate, and this is also preventing that code from being intertwined. So encapsulation, a simple definition from my perspective, is that encapsulation is all about hiding how we do something and only showing what we're doing. So we want to hide implementation details as many ways as we can. Not just hiding the code, but also hiding from our names and the way we name things. And there's one reason for that, which is that if I can hide it, I can change it later without having that ripple effect affect other pieces of my code. And that's what I want. Quality code is also assertive, and I don't see a lot of people talking about this code quality, but I think it's really valuable. Assertiveness means, and the opposite of assertiveness is inquisitiveness, where we're constantly calling other code to do our work. So assertive means that we have everything we need to be in charge of our own state, to be in charge of our own processes. Okay, and it's really helping us tell us where the behavior should be in our code. It should be with the data that interacts with the behavior. Okay? And then finally, quality code is non-redundant. Quality code is non-redundant. So redundancy in learning is valuable, it's good, it helps us learn. But redundancy in code is always a maintenance issue. So we want to apply that single responsibility principle. We want to make sure our code, everything is being done in a single place. And that also supports us in maintainability. So these 5 code qualities guide us. They give us direction. When we make code cohesive, it means that entities are responsible for themselves, and there's one place for if there's a bug, we can see that there's only one place that it would be. It makes it a little bit easier to find things. So I say increase quality today, and that will increase our velocity tomorrow. I'm not a big fan of measuring velocity because that's kind of a short-term thing, and what we really want to do is achieve the final result. And oftentimes we can sacrifice quality for speed, and we don't want to do that because it'll always wind up biting us. That's how I've seen it in the past. Okay, I have roughly 8 minutes left, and I want to touch on 2 other practices. My favorite practice, which is test-first development. And I have here this notion of dead end because there is a movement in the States called the TDD is dead movement. Maybe some of you have heard of this. And although they bring up some really interesting and valid points, they talk about test-driven damage, and I've seen this, where developers write too many tests and they write implementation-dependent tests. And if doing TDD, one of the values of it is to give us regression so that when we refactor, we can do it safely. But if we are actually doing TDD in a way that when we refactor our code, and I've had many people say this to me, it would take me about a day to refactor my code and about a week to refactor my tests, then clearly we're doing something wrong. because this approach, which was supposed to help us in refactoring, becomes a burden. And so we want to, I don't blame TDD for it, but I blame a couple of misconceptions for it. I want to touch on them with you. Because there's a lot of things that we call test, and I think it's kind of confusing to call TDD really the word test, because we think about, we suddenly put on our QA hat, and we think about what can go wrong. And this is not a good practice to do as a developer. When we're writing code, we have to think about what could go right. And then later we can go back and think about what can go wrong. I'm an author now, I've written a book. And I'm sure we've all done some writing, and remember in the early classes when you were in grade school learning about writing, they said, don't edit yourself when you're writing. Do you ever get that advice? This is really good advice, because if you try to edit yourself while you're writing, it's kind of a writer's block comes. But so instead, just spew it out, and then later go back and look at the code, or look at what you wrote, and then edit it. In fact, there's a whole range of job titles around being an editor, developmental editor, copy editor, etc. We should take the same approach in software development. When we're doing TDD, we want to think about what can go right, because we're not trying to replace QA. We still need QA to come back and backfill and look at what else could go wrong. But what we want to do is use our tests to articulate the behavior that we're trying to elicit. And then our unit tests become a form of documentation as well, a form of specifying the behavior as well. And then we can also get on the same page with the exact number and kind of test to write. When I teach, I have a TDD class, and when I teach it, I say in the beginning, my goal with you is to everybody getting to agreement when we're writing tests, so that for any behavior that I could give you, we all agree what the exact kind and number of tests are to elicit that behavior. And it's really powerful when everyone gets on the same page in that way. So again, we're not trying to replace QA, but we're trying to enhance it. It makes QA's job a lot more straightforward, and they can be more creative and think about things that could go wrong that are kind of not stuff that we are thinking about. So write good tests. And a good test is essentially a test that's unique. We don't want to repeat our tests over and over again, because that is a burden. We want to make our tests test behavior, units of behavior rather than units of code. And this is the other misnomer I see a lot of developers fall into, is they think that a unit test is a test of a function or a method. But a unit, the word unit, as far as I understand it, was adopted so that it represents a unit of independent behavior. So what we're really trying to build and what we're really trying to test are behaviors, not code. And this is good guidance when you're doing TDD. This gives us a positive feedback cycle, and then all sorts of great things can happen as a result. Suddenly we start to get on an upward spiral in our code. Martin Fowler wrote this book. I think this is a book that every developer should read. It's so powerful, because it gives us transformations to go from one design to another. And when you read this book and you realize that it's really easy most of the time to go from one design to another design, it's very freeing. It means that we don't have to get it right the first time, which I think is wonderful and valuable. So write testable code. That's Aristotle, by the way. I'm going to go a little fast because I only have 3 minutes with you. I've seen TDD fail, and I was alluding to that before. But if you focus on writing good testable behavior, and you think about writing tests for behaviors, this will put you in a lot better position when doing TDD than most people are. Sometimes managers say, well, how can I make my team do TDD? And you can't force this on us. But if we get an experience of doing it and we see the value of it, then we'll do it. So I am what Eric Gamma calls test infected. And that he uses this term to say how people feel when they really get TDD. It doesn't mean that I'm like religious about it or anything, and it doesn't mean that I think you should do it on every project. But I see that there is value in it. And so most of the projects I do are test first now. And then the last practice that I want to touch on in the last 3 minutes is refactoring legacy code. So we have this notion of investing in our code, just like in credit cards, right? And Ward Cunningham gave us this metaphor that we want to invest in our code. And if we carry around technical debt, it's just like credit card debt. It winds up eating us up. It'll cost us a tremendous amount. Whereas if we pay it off early, it'll cost us much less. So I work with the credit card industry, like many other industries, and there is a term that they have for people like me. They don't want you to know this, but I'm going to share it with you anyway. They call people like us, I'm a guy who pays my bill in full every month. They call us deadbeats. They call us deadbeats because they don't make any money on us. I want you to become a deadbeat with your technical debt. I want you to pay it off as quickly as you can. And you'll find that it oftentimes is most efficient. Now, there are exceptions to everything that I say and everything that anyone says. And there are times when we got to get things out the door. But we also want to then make promises to ourselves to later go back and clean things up if we can. Okay? So when code needs to change, because there's so much legacy code out there now, there's not enough people in the world to fix it all. So we got to figure out, well, where do we focus on refactoring and cleaning up our legacy code? And we want to make business cases for this, so it makes sense. And one business case is that if we need to go in and change the code, we would like to refactor it first. Imagine you're about to make a dinner party and make this beautiful meal for your friends at a dinner party. But your kitchen is a mess. You didn't clean it up for like 3 weeks, and you would probably not start cooking your dinner before cleaning up the kitchen, right? You'd probably start by cleaning the kitchen. And that's what we do when we refactor. When we need to make a new feature in code, we really have two things that we need to do. First, to create that space so that we can add that new feature, and then to add it. If we break it into those two steps, it's really powerful and really much easier. Most of the time, what I see is developers try to do both of those things at the same time, and that's where the hardness comes in, where the difficulty comes in. So there's a whole range of refactoring techniques, but in the next 20 seconds, I really can't cover them. But you can find it in my book. We, again, want to refactor to accommodate change. Make sure that it's easy to make changes. So we have this notion of refactoring to the open close. Again, I talk about it in the book, but with 8 seconds left, I can't talk with you. But I want to share with you this one thing, which is a saying that I have, which is do it right the second time. And I'm sure you've been told do it right the first time many times in the past. I want to suggest that doing it right the first time is oftentimes wasteful in software development. Because if we only have one example of something, it's hard to determine what the abstraction should be for that. So very often, if I only have one example of something, I'll just write it concretely. And I'll wait until I get the second example. And then, with 2 examples, I can determine what the right abstraction is. And I find that it's more efficient to do it that way. Okay, well, there is a place for you to fill out feedback online. Of course, we've just scratched the surface. It's just a little taste. If you'd like to know more, I've written hundreds upon hundreds of blog posts. You can go to my website, tobeagile.com. I've written about these subjects. I also have a monthly newsletter, and you can follow me on Twitter if you'd like to read my book. And I also teach classes for this stuff. So I'll be here for the rest of the day if anyone would like to talk. And I want to thank you very much for your attention.
Thank you very much, David. This was an awesome talk. Let's roll to questions.
Oh, good. We get some questions.
Oh, there we go. Awesome. So, the first one. Why does the real message of the Agile Manifesto keep getting lost during every single Agile transition at every single company?
Thank you so much for asking that question. That is an awesome question. Because I had a theory, and I'm believing that my theory was completely wrong. My theory was that the people who started Scrum were all about making money, so they created this certification mill. And this is a popular myth in our industry. But you know what? I got a chance to talk with some of these people, and that was not their intention. Remember those sentences I read you from the back of their book. They intended to create an environment to support you in doing XP. So whose fault is it? Us. And maybe because school was not that valuable to us, so learning these new practices, we've resisted them. Also, it's easy to train a Scrum Master, much more difficult to train a team. We're akin to doctors. I believe that what we do is some of the most complex stuff in the world. And we just are expected to learn this by osmosis? I don't think that's a really valuable or useful way. So we really have to draw on each other to learn. And one of the ways of doing that is mentoring. The other ways of doing it is to find good training and something that's out there. People, like many of our speakers here, have answers to questions that are burning in you that have been challenging to all of us. And so if we learn from each other, I think we can do a much better job.
Thank you. Yeah, what makes you feel so enthusiastic about this topic Can I get some?
Thank you again, thank you. Well, that's another really, really good question. And the answer for me is, first of all, because I thought we would never get here in our lifetimes. But I think that we do have real answers in our industry. Some of these ideas coming up. Again, you talk to people like Llewellyn or Aldo, they haven't written books yet, so it hasn't really disseminated very much yet. But they do have really amazing answers. The other reason that I'm really excited about this idea is that we have answers in our industry for the rest of the world. Think about this. So much science and sociology are overwhelmed with complexity. We deal with complexity all the time. We have to, because that's what software is about. So we have lots of ways of managing complexity. They can learn some valuable lessons from us. So I'm really excited that what we're learning in our industry is not only helping us build better software, but helping us become better human beings and also do science better in other fields as well.
Cool. My team always has the same issues every retrospective. How can we actually make a change when the change has to come from the executives?
Ooh, yeah. Not so easy, but we got to get everybody on board, right? Agile, just in the IT world, I mean, unless we get support from executives, and this is one of the prerequisites of XP. So how do we train them? How do we get them on board? Part of the answer to that is to speak their language. We have a much broader vocabulary than most business people. Business people know two words, cost and profits. So we got to, a lot of times developers will say, well, I want to refactor this code, and the manager will say, well, why? And it's like, well, because I really want it to be clean, and all of these things they don't hear. But if we say to them, I want to refactor the code because it'll be cheaper to add this feature over here. It'll be cheaper to clean it up first, like cleaning the kitchen before the dinner party. That's something they can understand without knowing too much about the technical side. So I think part of it is really speaking in their language. We both want the same thing. Honestly, every developer I've ever met wants to do a good job. We just don't know how to speak their language sometimes. That's a short answer for that. Are we okay? Or
yeah.
Do one more?
Very cool. We have time for one more question.
Okay.
TDD does not mean comprehensive testing. I believe this is a huge oversight. What is your opinion?
Test first does not mean comprehensive testing. Yes. And because it's like saying, when I write an article in my language, my spoken language, I have to have it perfect when I first write it. And that's an incredible amount of pressure. Imagine if in the video industry, if you were making a movie and you had to get it right the first take every time. I think it's much better to write the code thinking about what can go right and then later go back and do, because otherwise we're trying to do too many things at the same time. And that's really where we fail as developers. We try to overload ourselves and then we fail at it. So making it simple for us and making it focused for us, I think we can have a much higher probability of success with it. That's my opinion again.
All right. Huge applause to David again. Thank you so much for the energy this early. Thank you so much for the awesome talk.
Thank you. Thank you very much.